length. Question 6. The border of a garden pond consists of a straight edge AB of length 2.4 meters and a curved part C as shown in the diagram. The curved part is an arc of a circle, center O, and radius 2 meters. Find the length of C. We need to find the green part here, the length of C. So if I say the circumference, which is right here, circumference of the circle is 2 pi r. The arc of the sector here, so that's an arc here. The arc of the sector AB is, let's call that L and subscript theta, because the angle here is theta. So that will be L theta, and that is R times and the angle theta. If I could find that length of the arc AB, I could take it away from the circumference of the whole circle, and then I'll find the length C that is being requested. So I could find that. So I could write the formula that I need, which will be C will be equal to 2 pi r circumference, take away the AB minus L subscript theta. In order to do that, I need to then find that angle theta. So to find the angle theta, I could divide that length into 2, divide the angle into 2, and call that alpha. And this length will be 1.2 because 2.4 for the whole length. So at this point, I could use sine. Sine is opposite over hypotenuse. So I could say sine of alpha will be equal to opposite of alpha over the hypotenuse. So that will be 1.2 divided by 2, which will mean that implies that alpha will be equal to sine to power minus 1 into bracket 1.2 over 2. So what I did was I divide both sides by sine. So that sine, what I'm saying is I divide that by sine, and then I have to divide this bit by sine as well. So that sine cancels sine, and 1 over sine is that's 1 over sine. 1 over sine is sine to power minus 1. So that's how I get that. By alpha will be equal to, if I punch that into the calculator, well, we want shift sine to get the inverse sine, and you want the fraction key, 1.2, bring the arrow down, divided by 2, arrow to the right, close the bracket, and press equals. We get 0.64. So I'm going to write that down. So that would be 0.6435011088. Now I need to multiply that by 2 because you see theta. So in this case, theta will be 2 alpha because that will give it theta. So multiplying that by 2 will give me, so I just bring that back and times it by 2. So I get 1.287002218. So that's the angle theta, and what I need to do is to use the formula, this formula here, because I now know the angle theta. I need to find L, that length here. So therefore, L subscript theta will be equal to radius times theta. So that'll be 2 times theta, which will be equal to, again, all right, so I just bring that back, times it by 2. So that'll be 2.574004435. Right, so that's that length here. So what I now need to do is I need to work out the difference now between I need to find the green part here, which is using that formula now. So C will be equal to, well, we know what R is. That's R is 2. 2 times 2 is 4. So that'll be 4 pi minus L naught, L theta, so minus 2.574004435, and that will be equal to, so if I again bring that to calculator, and all I need to do now is do the, so I need to do 4 shift pi here, so that's the pi, minus the answer, which is 2.574004435, and I give 9.99. So into 3 significant figures, that will be 9.99 meters. So the length, major arc, so that's the major arc. So if I bring it down again, so what I've just done is we've calculated the major arc. That's what we're looking for. The minor arc is the AB. So I had to find the minor arc, which gives me the 2.57444004435 meters. That's the minor arc. But we need to find the major arc. So the major arc is the part of the garden we're looking for. And that is how we found that. And that happens to be 9.99 meters. So that's what the question is all about, finding the major arc. So that's the major arc, and AB here is the minor arc. The angle for the major arc will be the angle here. So I'll call that beta. So that will be the angle for the major arc. But the angle for the minor arc is theta, that bit here.